Okay, so let's start. Hello, our topic for today are Kotlin sequences, and we're going to talk about the Kotlin functional programming for Java developers. Like no Kotlin knowledge is required for today. So let's go ahead. Few words about me. As Piotr said, my name is Grzegorz Witczak, which is impossible to pronounce if you're not Polish. So everybody calls me Greg. I'm a backend developer for 8 years, focused on Java and JVM, and I teach people how to code in a free time. So if you need to remember just one sentence about this presentation, then it should be this one. Like the sequences are the Kotlin's alternative to Java streams. We can do more or less same or very similar stuff with it, but it's more of a like Kotlin way. So let's jump straight to the code. We're going to start with a regular Java, bit of a hello world code. So we're building up a list from given British names, and we want to process them a little bit. So in this kind of like classic procedural approach, we'll start with a for loop. So we're iterating over all the names in our list, and we check whether the given name starts with a letter B. If it does, let's transform it a little bit by converting it to the uppercase, and let's add it to the results list that we need to kind of like prepare upfront. And the result of this code would be the three names, Bob, Bernard, and Brandon. And that's like, I guess, the super simple Java code. We're doing some processing on a list. And we can do this in a different way, starting from Java 8, using the Java streams. So let's have a look at this code. First of all, we start from a same list, and we need to convert it from the list of strings to the stream of strings by calling a stream function, stream method. And then goes the bit ugly part. Because we need to call the filter method on a stream. Filtering means basically it's a replacement for an if statement, as we had it in a slide before. So we want to kick out all the names that doesn't start with a B. So in order to do that in Java streams, we need to provide the instance of the predicate interface. And since we can't kind of like instantiate the interface, we need to create an anonymous class that would implement this interface. It's like a typical Java code, but to be honest, it's like completely ugly in this syntax. But yeah, well, that's the way to go. So we type that the string needs to start with a B, and then it would work as this if statement. Next, we have the map function that's actually converting one element, the string here, to, in our case, another string. And you can see that there is like a lot of boilerplate here and really a small one-liner of actual code and something that we need. So this is like really, really ugly syntax. And after all, after we do this processing, we want to wrap everything up back to the list from a stream. So we call the collect function and tell that we want to wrap everything to a list. Of course, the result would be exactly the same. How do you like this code? It's ugly. You can't argue with that. So, but of course, it's not like the Java is so super ugly. Together with Java 8 streams, the Java lambdas were introduced, which are the kind of like shorter way of providing the same information. That's really like more civilized. Because here we have exactly the same code, but to a filter method, we just provide the lambda that the string will be just checking whether it starts with a B or not. And all the types that were present on a slide before would be just automatically filled up, and Java can like guess them on a compilation time. But I guess if we compare the bytecodes, it would look more or less similar in both cases. But the syntax is much better. So we filter out the names that starts with a B, we convert them to uppercase, and we collect them to a list. Same things, but looks much better. Okay, so enough about Java. Let's jump to a Kotlin. If we want to do the same thing in Kotlin, we have two ways to go, except the procedural approach. We're going to skip this one today. So we build up a list, and then we can operate directly on this list using the kind of like functional code. So here, note down that we are working, give me a sec. We have the list directly, the names that we had on the first line, and we call filter, map, and toList methods on them. So it's going to be like super important in a minute, but the code more or less looks exactly the same. We filter out, we map the values, and we wrap it back to the list, getting the same results. Okay, and as I said, this is the Kotlin functional approach, but it's not a sequence code. So we're not using Kotlin sequences here. We're using them in next example that looks exactly the same, and only difference is the call to a sequence, as you can see it here in a red frame. What's the difference? We're going to talk about this one in a second. The result is exactly the same. Okay, so I did some performance tests on this code and all the other code that I'm showing to you. So I've been using the Kotlin X benchmark library. I've run this test multiple times and excluded the warm-up time on the MacBook, and using not only like 8 names, because it's not enough to check anything. I've downloaded a set of almost 7,000 British names from some data science site. And we're going to operate on those names during the whole presentation. So what about time? If we think about this regular classic procedural approach, it required 35 microseconds to process on average. If we have a look at Java Stream approach, it took 34 microseconds. The Kotlin non-sequence approach, 30 milliseconds, and Kotlin sequence approach, 31 microseconds. More or less, all those values are the same, because the difference here is so super small, and it's somewhere around the kind of like error rate for the measurements. So we can like just easily say that it all takes the same time. So what's the difference between all those 4 approaches? I would say syntax. That's the core thing. So we'd rather like to use Kotlin because of its better syntax here, and not because of some performance difference. Okay, that's the hello world example. I have also another one, also quite simple. The first B name. So the first name that starts with a letter B. In order to do that with Kotlin and the non-sequence approach, we just grab the names, we filter out the ones that start with a B, and we call the first function. That would just give us the first name that's matching the rules that we specified. With sequence, code looks exactly the same, but we have a sequence call before, and we convert the list of strings to the sequence of strings, sorry. And we can also use Java streams directly from Kotlin. So you don't need to kind of like mix the 2 languages if you want to work on Java streams for some reasons. As you know, kind of like Kotlin works well together with Java, and you can use whatever you want. Everything's available. So it's, of course, also a valid code. What about time here? If we go with the non-sequence approach, we need about 20 microseconds to execute this code. But if we go with the sequence code, the difference is really, really huge. So we're talking about like orders of magnitude difference. And this isn't a mistake. It's like the actual time that it takes. And we got a similar time with Java streams. Do you know what's the reason and what's the problem here? Go ahead, Andrzej.
More or less, this sequence executes every part of this huge chain one by one for each child, right? Instead of like accumulating the results of the first and then passing it to the next.
Yeah, exactly. That's the problem. So we're doing the whole processing at once we call it, and we're not kind of like postponing it. Because what we should do is that we should go with more or less like a lazy load approach and do all the calculations only when it's necessary. So let's jump a bit into this example, and let's have a look about the Kotlin's internals in this matter. So when we call the filter function directly on a list, what it does actually under the hood, it creates the new array list, and then we have a for each loop with an if statement that adds up the elements to this newly created list. So that's like a typical code that we would write in a procedural way. But then the nice part is that when we just call the first method, we're just reading the first element out of our list, and that's it. There is nothing extra work that needs to be done. But yeah, well, why do we need to process all the elements in the first place, since we're only interested in the first one? And we need to process all like 7,000 names. So this is totally like extra work that isn't needed, and we should skip it. And we can do this by using sequences. So let's have a look at two sequence operation types. We have this like super simple sequence that we filter, map, and wrap to list, no matter like what's inside. The filter and map functions are so-called intermediate operations. They aren't executed at the exact time when we call them, but they are more or less scheduled to be executed later when it's absolutely needed. And when is it needed? Once we call the terminal operation. For example, to list or first or anything similar to that. And the operations that doesn't give us a sequence as a result, but some actual final terminal result that we're interested in. So let's analyze this example. The filter is the intermediate operation, and the first one is the terminal operation. When we call filter on a sequence, we're actually creating a new object of a class filtering sequence, and no like actual code execution and actual list processing is done here. We're just kind of like scheduling that this predicate that we passed as a parameter, so the starts with B, will be just executed somewhere later. And next, when we call the terminal operator, like first here, we actually grab the iterator for this sequence, and here try to retrieve the first element if it's available. So actually the whole execution will take place once we call the terminal operator, and before we're just kind of like scheduling that something needs to be done with this sequence once we try to get the results. So that's the core difference here. Okay, let's have a look at third example. Now we'll be working again with the same data set of British given names, almost 7,000 of them. They are stored in a CSV file like this, and we have the data class and enum class to store this info. It's quite simple code, so I guess you all can read it. So now with this exercise, we'd like to analyze only the long names, meaning five letters or more. And we'd like to count how many names are available. And we want to display a separate counters for boys and girls. So the result should be like we have 2,000 names for boys and 3,000 names for girls, or like something like this. This is the result that we want to get. So let's have a look at Java stream code that we need to write to get this result. So first of all, we convert the list of child names into a stream of child names. Then we need to filter out and to keep only the long names that are 5 letters or longer. That's quite simple. And now we need to group them by the gender that we have here. So we use the collect function, collect method, and the grouping by. While thinking about this grouping by collector, think about group by in the SQL relational databases. It's more or less the same idea. So we want to group everything by gender, so have a separate group for boys and separate group for girls. So that's what we do. And we have actually quite a nice collector built in the Java streams. That's just collector counting. So it would count up all the elements and we get the exact result that we were, well, that wasn't a perfect idea. Exact result that we wanted. So that's quite nice. This code, I would say it's quite cool. Now let's do the same thing with Kotlin. We start in exactly same way. We convert the list of child names into a sequence of child names, filter out the long names, and group by gender, and then call the each count function. It's the same code, but the syntax and the actual calls are different, slightly different. Personally, I find this one much more readable and just like better, but you can tell that it's not a huge difference and you can get used to this Java streams specifics, but Kotlin is better and that's like why we are all here. Okay, but let's talk about the performance. When we try with the stream approach, we need 100 microseconds to execute it. When we go with a sequence approach, we need slightly more time. And when we go with a non-sequence approach, we need even more time. Where does this difference come from? It's a bit of a mystery, but it can be also the kind of like something around the margin of error. So it can be just coincidence. The difference here is kind of like so small, we can't really tell for sure that one is slower than the other. Those are just results that I got. So that's why I present them. I'm not going to lie here and kind of like trick with the numbers that went differently. But yeah, it's kind of like safe to assume that all three approaches would give us quite a similar execution time. Okay, and now the fourth example, the most sophisticated one. We're analyzing only the long names. We want to display the separately names for boys and girls. And now we'd like to display the actual names and to have them sorted alphabetically. Okay, and this one is going to be a bit more fancy, and we're still working on the same names. Okay, so what we need to do, first of all, we convert the list of child names into a stream of child names in Java, and we filter out the long names. Here you can see that I'm putting in a comment what's the type of the thing that we're operating on. It's also something that IDE is going to do for you, and it really helps a lot with reading code and seeing what's going on. So that's really a nice thing. So in Java, we need to group by the gender, and as a result, we'll get the map of gender and a list of this complex child name object. Okay, but it's a map, and like we're done. It's not a stream anymore, and we can't work with it further. So what we need to do here is that we need to convert this map back again to a stream, first by calling the entry set that would give us just a set of map entries, and then convert this set to a stream. So as a result, we're getting the stream of map entries of gender and the list of child names. That's quite a lot of generics already. Oh, okay, it looks slightly different on my machine. But yeah, okay, we still got a stream, like second stream, and we can keep on processing. So now let's convert the values into something that we're looking for. So we're going to convert each map entry to a pair of a gender and some sorted set of actual names. So the key here in our pair would be still the gender. And the value is going to be, once again, we'll just grab a small stream out of the names, out of like a real, the child names, and we're going to convert it to a stream and then map to get only name. Okay, now it's better. So like, if you see the code here, we have 3 streams code, like the top stream. In the middle, we're converting map back to a stream, and we have even a stream inside. This code is really a mess. So yeah, well, it took me like half an hour to write this, and that's like not how it's supposed to be. Okay, yeah, and then if we want to wrap everything up into some sorted collection, we need to collect it to a tree set that we provide on our own. And as a result, we're getting a stream of a pair of a gender and a sorted set of strings. And now comes the easy part. We can just wrap it up to a map. Yeah, the easy part finally. So you can see that we needed like 12 lines of code to get this example to working. And if we think about this code readability, it's poor, and that's like a delicate word for it. So yeah, well, it would be a mess to maintain in like few months, to like somebody else to have a look at this code and trying to fix something here. So yeah, well, I wouldn't recommend this one, but we get the correct result. If we run this code on this small list of 8 names, we would get results like this. So that's like a general idea, but of course I've run this code on 7,000 names to get the right numbers. Yeah, very complicated. Now let's do the same thing with Kotlin. Starts as always. I'm not going to repeat myself third time. After filtering out, we're grouping by, and here comes the first difference with the Java streams. We have quite a lot more functions available for sequences in Kotlin rather than for streams in Java. And the group by comes with 2 parameters. So we can provide the grouping by for the keys and for the values, which are the values that we want to extract. So here I was able to kind of like convert okay, now it's better. I was able to convert from this complex child name object directly to a string. So I'm one step closer. The next step here would be to convert the list of strings that we have here into a sorted set of strings. And this comes with a quite easy piece of code. I just want to map values from my map and grab them all and convert to a sorted set. So I would say that it was quite straightforward to write. And what's the next step here? There is none. That's all. Like, we need 3 logical lines of code instead of 12, and we get the same result. And the code is like super readable, especially if we compare it with a stream code. So kind of like usually when you watch some like presentations or some blog posts about streams or sequences, they mostly cover the really basic examples like the 3 I've shown before. But if we go with really more sophisticated stuff, more complex stuff, that's when Kotlin is really great, and Java streams are like painful to work with. So this is kind of like a big thing here, at least for me. If we have a look at the time in all 3 approaches, we get basically the same time, more or less 1.3 milliseconds, and that's it. Like, there is nothing significant here, so it's not worth talking about. So now the question is, is Kotlin a functional programming language? What do you think? Yeah. Yeah, exactly. Piotr said that it has some functional features, but it's not purely functional. And that's exactly the thing, because both Kotlin and Java are object-oriented programming languages. And this is the kind of like core, and this is the core idea behind both languages. If we're stubborn, we can write code in a procedural way. If we write everything in Java using the static keyword, or if we put a lot of stuff into Kotlin's object, we can kind of like skip this objective part more or less, but it's not the way how we code usually. And if we want, we can work with data collections in this functional programming approach, as we've seen today, but it's not mandatory. You can use it, you don't have to use it. It's totally up to a developer to decide. So yeah, well, if we map over a list of values without a for loop, is it the functional programming already? It's a small piece of functional programming, but we're still writing more or less in this object-oriented way. If we think about, like, as Piotr mentioned, like fully blown functional languages, we need to have a look at something completely different. For example, at Haskell, which introduces like a completely different way of thinking when we code. And yeah, it's kind of like, at least for me, it requires really kind of like a switch in your head to start coding a bit differently. But Haskell, like, it's a completely separate technology. And here we're around Kotlin and JVM. So if we want to think about more functional approach and still stay within the JVM world, we should try Scala. So that's kind of like the closest you'll get to real functional programming while still staying in a JVM world. Okay, so now let's compare the Kotlin sequences and Java streams. What are the benefits, and are there any problems? So the sequences are the preferred way of doing functional programming in Kotlin. And the sequences work on all Kotlin platforms. So it's not only the JVM, it's also the JavaScript native and whatever comes in a future. It will all work, and we don't need to care about this. For sure, we know that Kotlin sequences have easier syntax and more features. You can't like argue with this one after today's presentation. And the one problem that we have is that sequences lack built-in parallelism. So let's talk a bit more about this one, and let's see how it's being done in Java world. So with Java streams, we can create either the single-threaded stream, as we did in all the examples, or we can go with the multi-threaded parallel streams. Sounds amazing, because we get the instant speed boost with 0 extra code when we use it. But can we just like add parallel and everything's going to be cool and faster? Yes, but no. So as always with the concurrency, we need to take care about all the concurrent problems that can happen, like some race conditions, values overwriting each other, etc., etc. It's like a topic for a whole separate presentation. But the one problem that Java parallel streams gets really of bad fame and bad criticism is the default fork join thread pool that's being used under the hood. It's the thread pool that's being shared across the whole application, and this can result in unexpected performance problems. Let's think that we have a web application that's accepting 10 requests at the same time, and processing each one of the requests uses the parallel streams. What we are having here is that 10 threads, because we get a separate thread for each request handling, waits for the parallel streams for this one single thread pool to finish the execution. So we were supposed to get the performance benefit and to have everything calculated faster. But what's the actual result here is that our processing waits in queue till the rest of the stuff gets calculated, because we share the same fork join thread pool. So you can really read a bit more about this, and there are like a lot of blog posts about this. I've even linked some of them. But yeah, remember that the parallel stream, it's really cool if you write just a small application that you're totally in control with. But if you try to use it in a bigger application, then it can hurt you. So this is really something to watch out. With Kotlin, we don't get to have these parallel sequences in a such easy way, but there are some ways of having it more in a more parallel way, but it's outside of the scope today. Okay, if you want to learn more about these topics, I've linked few articles here, and I've also published the benchmark code on GitHub, so you can review it and run it on your machine. So to sum everything up, the sequences are the Kotlin like replacement alternative for Java streams. They are lazy loaded, just like streams. They have comparable performance, but much better syntax. They work with the non-JVM Kotlin code, and they don't support parallelism in a way that Java streams do. So that's like a one minus. And in general, my goal for the last half hour was to convince you that sequences are quite cool. So I hope that I was successful in this attempt. That's all I had planned for today. Thanks. If you have any questions, just go ahead. The Slido, it's empty. Or do I need to click something here?
I guess it's just empty. But if I have one question. So
go ahead.
Have you tried actually combining these sequences with coroutines?
I've actually haven't tried it. I just read some code and some Stack Overflow answers and kind of like decided that it's a bit outside of the scope because I have only half hour.
Sure. Yeah.
But yeah,
But
I guess
work,
you
in theory.
Yeah, like yeah, well, it will work for sure if we're just kind of like thinking, because it's like we have a separate coroutine and then the code that needs to be executed.
Exactly.
So there's nothing not to work here.
Yeah.
But like, you must say that using just calling this parallel stream, it's super convenient and you don't need to think about all the coroutines and introducing and having all the stuff. So it's much easier. But yeah, as always, you can like just write in a coroutines any code you want and it will work. So no difference here.
Yeah, I can imagine some kind of extension function that is called like parallel sequence, and it does exactly the same, but with coroutines. It may be worth checking out one day.
This would be really cool. There is something comparable to parallel streams in Scala. Like, I guess you can just call .par and it would kind of like convert it to a parallel way. But yeah, we don't have it in Kotlin yet.
Sure. All right.
Anything else?